Okay, so let's continue. Please help me confirm. What are you seeing on your own screen?
Number 1.
Number 1, but you're seeing the YouTube, huh?
Yes, sir.
Good. Okay, so did you see the way I solved it out? Like I tried to explain the other concepts there.
Yes,
The
sir.
time rate of increase in velocity is change in velocity over time, which we all know as acceleration, isn't it? But force is actually mass times acceleration.
Yes.
Speed is distance over time. Momentum is mv, mass times velocity, okay? So let's go to the next question. Yeah, you can continue now.
So momentum is
Please continue.
so I said momentum is what?
mv, mass times velocity.
Oh.
That's the follow-up to the number 1 question, Abby.
Yes, sir. This is number 2.
Okay, so this is number 2. Okay, so what do you think is the answer for this number 2?
Number 2 is the momentum.
Momentum bar? Abby?
Yes, sir.
Yeah, that's the answer. So why is momentum the answer?
It only has magnitude.
It only has magnitude. Jesus. Are you correct? They are asking you for vector quantity. Vector quantity are those ones that has both magnitude and direction. So momentum cannot be the answer if it only has magnitude. Chick, are we together?
Yes, sir. Sorry, sir.
Okay, so it's actually, it has both magnitude
and direction.
and direction. Now, be good. So if you're looking at my screen now, you see that vector has size, which is magnitude and direction. Whereas
Yes.
scalar have only magnitude, they don't have direction. So examples of vector is displacement, which is distance in a specific direction. Whereas scalar is distance, but no direction. So example of scalar is distance. For example of vector is displacement. Can you see that?
Yes, sir.
Can you see that?
Yes.
Good. Another example of vector quantity is velocity, because velocity is displacements over time, whereas speed is distance over time. So making speed a scalar, whereas velocity is a vector quantity. Are we clear on that?
Yes, sir.
So why momentum is the answer is that momentum is mv, mass times velocity, and you know velocity is already a vector quantity. Can you see momentum?
Yeah.
That's what I'm writing now. Can you see it? Momentum equal to mass times velocity, because velocity is a part of it. So that makes it a vector quantity, Abby.
Yes, sir.
And that's why B is the answer. So do I leave you to copy it down? What's on the screen?
Okay, so let me quickly copy it.
So can you see other examples of vector quantities? You have momentum, you have weight. Weight is directed towards the ground. Then you have acceleration too, because acceleration is velocity over time. Because velocity, a vector quantity is already there. So it makes acceleration also a vector quantity. Whereas for scalars, you have things like volume. There's no specific direction. There's speed, there's energy, and others.
Yes, I've written.
You've written them, huh?
Yes, sir.
Okay. So from this sketch now, you've learned about scalars, you learned about vectors at the same time. So it's very, very important. Do we move forward?
Yes, sir, we can.
Okay, so let's look at question number 3. Can you attempt it?
Yes, I can.
Okay. So it says, in elastic collision, momentum is conserved as well as dash. What else is conserved apart from momentum?
As well as kinetic.
As well as kinetic energy, Abi?
Yes, sir.
Yeah, so you're getting the answers, but the reasons behind them is where you're having problems. So I'll let it play out. So take note of what is being written on the screen so that you see the way I explained it. So do you know what elastic collision is? Somebody is calling you back.
No, sir.
Okay. So an elastic collision is a collision in which there is no loss in kinetic energy. That simply means kinetic energy is conserved. In elastic collision, kinetic energy is conserved. We also have your momentum conserved. I've told you about this our YouTube channel, Abi. Did I tell you about it? Tika, are you there?
Hello, sir.
Yeah. So an elastic solution is the sort in which both, what's it called? Kinetic and this thing is conserved. So let's move forward. Question number 4, induced current.
So I'm coming. Elastic collision.
Okay, is a type of collision in which there is no loss in kinetic energy and momentum.
Okay, sir.
Yes, so let's move forward to question number 4.
They said the induced current in a coil always flows in a direction as opposed to the chain that causes it. This is known as Lenz's law.
Lenz's law, huh?
Yes, sir.
Nice one. You know that one?
Yes, I do.
Yeah. Okay. So what about I think was it your what's it called? I think it was your uncle told me that he has explained Lenz's law to you and other similar laws.
Yes, he has.
Okay, so let's just wait for what is being written on the screen so that you get the concept. Get to see the other laws and get the background of what is being said.
Okay, sir.
Okay, I'll just move forward. So let's look at question number 5.
Number 5, which of the following can be used to compare magnitude of charges on two given bodies?
Yeah, to compare the magnitude of which of the following instruments can be used to compare the magnitude of charges in two bodies?
I put gold leaf electroscope.
Gold leaf. Okay. Yeah. Because electrophoresis is simply using transferring and storing charges. I think there was a similar question to this on the 2018. Can you recollect that 2018 where I drew the diagram of gold leaf electroscope as well as the electrophoresis for you? Can you remember?
Sam, I don't think I'm looking at the 28 now for the question.
You're looking at what?
2018 to find that question.
Okay.
Okay, in number 20. They were
actually,
asking about which possess equal and opposite charges are separated by a dielectric.
electric. That one is capacitor. Huh? Yeah. I think that's where we did that.
Yes. Yes, sir.
Okay. So you can see these are the gold leaf electroscope that is being drawn. So it's used to dictate and test small amount of electric charges.
So I said the ebonite rod is used to rub animal.
Yeah, if you want to create a charge, a negative charge, so you can use when you rub ebonite when you rub it on an animal paw. So you can see the sketch of the gold leaf electroscope. It's similar to the one I drew for the other one, right?
Yes, sir.
So you can use it to detect and detect small electric charges, as well as compare the magnitude of charges in two different bodies. So let's look at question number 6. Can you solve number 6? Mass of 2 kg released from a point 100 meters above ground. Calculate its kinetic energy, 80, from the point of release.
Question number 6. A body of mass 2 kg is released from a point 100 meters above the ground. Calculate its kinetic.
Okay. The network went bad, huh?
Hello.
I can hear you.
I don't understand. Sir, can you hear me?
Yeah, I can hear you now.
I said, please, I don't understand this.
Okay. The calculation was done for 100 as a whole to get this. So it was now done for 20. That is from here to here to get 400. So from here to the point 80 now will now be this one gotten for 2000 minus that gotten from for this remaining 20, which is 400. Is that?
Why are we minus?
That's what I'm saying. Like from this point down is 20 that is remaining. Can you see this is 80 minus 20? What is remaining here is 20. So the one he had here, simply what is total here minus what we have here to give us what is here. So that's why, because we had 400 there, they say 2000 minus 400, they give us what? I'm going to look at the next question.
So I didn't really get that one.
Yeah?
I didn't really get that clear. Is it, why did they have to reduce that 20? Is it because you are trying to get the same height?
Okay. Let me go back. Huh?
Yes, sir.
Followed by Mexico, Russia. So let's say that the height is from here to here, that's 100. Yes. Then let's say from here, instead of from the normal height, from here down here is 20. So we'll get this. So the kinetic energy here minus that of here will now give us what would have been for this 80 meters. So it's the same formula that we use, MGH, the same MGH, but at different heights. So the total kinetic energy here minus what it is here from this side will give us what will be from this side, up, down.
So why didn't we use 80 instead of 20? Since they said calculate 80 meters from the point of release.
Yeah. Because this 89 is not getting to the ground. So we assume a height that gets to the ground. Same control for both of them. Did you try solving with 80? What did you get? If you try solving with 80, you get 2 times 10, which is 20. 20 times 8 is what? It's still 16.
Yes.
Abi?
Yes, sir.
So it gives you the number.
If you use, you get 400 joules.
Okay. So if you use 80, that means you don't have to use 2000 again. Then you are solving it straight up.
Okay, sir.
Yeah. So let's check out question number 7. Are you seeing number 7?
Yes, I'm seeing it.
Okay, which of the following waves is non-mechanical? So mechanical waves are those waves that you need material medium for their propagation. Without a material, they cannot propagate. Whereas electromagnetic waves, they can travel through the vacuum. So which of the following waves is not mechanical? That means which of them is not mechanical? So examples of mechanical waves like water waves, sound wave, waves in pipe, strings, and rope, all of them need medium to transfer. Whereas electromagnetic
radio waves.
So which one is the answer? Radio, ba?
Yes, sir.
Yes.
Yeah, it's radio waves, yeah. Because the other ones, they need a medium. There has to be a medium for them to propagate it or to transfer. For you to get to feel them, there has to be a medium. Whereas the electromagnetic, so the concept behind this simply tells you that there are two major types of waves based on their propagation. You can have mechanical waves, you can have electromagnetic waves. So the ones that travel through vacuum, they are known as electromagnetic, whereas the ones that use medium, they are known as radio wave, mechanical.
So, sir, which
So other examples,
is transverse wave based on?
yeah,
Like, what type of wave is transverse wave?
no, this one is you're classifying based on their whether they need a medium or not in order to be propagated.
Okay,
So
what
it's
about transverse?
different from when you're looking at whether it's transverse or longitudinal waves.
Okay,
But
sir.
we still see questions on those ones, but that's not what we're looking at. Yeah. Talk to Dorcas. Yeah, let's look at question number 8.
Sir, should I read it now?
Yeah, read it and answer. Which school
A
is that?
loaded spring set in simple harmonic motion.
No.
The force that tends to restore the load to its equilibrium position is A, adhesive, B, elastic, C, frictional, D, gravitational. So I put elastic.
Yeah, it's the elastic. The elastic. Because the elastic, why is it elastic? Because of the string, the spring. The spring is an elastic material. So it's the elasticity of the spring that tends to like bring it back to continue to make that to and fro motion. So when you're talking about gravitational, then there's no string. You just drop something, the force of gravity between the earth and that body gets them together, or the force of gravity between one body and another body gets them together. But elastic, you're talking about the string. That's what keeps it in the to and fro elastic motion. Adhesive, you talk about two different substances trying to cling together. Then frictional force is the opposing force that makes something not to move smoothly on another body. That opposing force that acts in the opposite direction. Is that you? Click log out, you see log out on top here, then you log in. Can we move forward?
Yes, sir.
Okay.
Which of the following cases cannot produce total internal reflection?
Okay.
Which of the following cases cannot produce total internal reflection? A light traveling from glass to water, kerosene to air, I put air to water
Air to water. Yeah.
because total internal reflection travels from a less dense medium to a more dense medium.
Okay. I hope I have those ones here. The next one I have here is 15. Let me see. 29. Wow. I have this 20. Okay, so continue. But I think I don't even have all of them here. I'm just playing through. So maybe we'll still do it the way we did the last one.
Number 10. Okay. Sir?
Yeah, let's still do it the way we did the last one. Let's finish up the ones I have here.
Okay.
Then we'll do the ones I don't have, yeah, so that it will be better understood. So let's look at number 15. So just the way you did it before, mark out the ones that we've done so that in class that we are meeting, I must have sorted out the other ones.
Okay, sir. Okay, so number 15 now.
Yeah.
Yes, sir, why is the answer not A?
For this number 15,
Yes.
okay. So it says that which of the following graph of change in Q against potential difference across a capacitor is correct? So Q is directly proportional to V. The more the charge, the more the potential difference. So more charge, more potential difference. That's the relationship. So this is the graph for relationship between directly proportional quantities. So Q is directly proportional to V. So if it's proportional, then this
Okay.
should be the relation. But if it is inversely proportional, then this is the relation. You get
Yes, ma'am.
what determines the graph is the relationship between the quantities. Well, the quantities are directly related. If as Q is going up, V is going up, then it is directly proportional. And this is the relationship for that. But if they are inversely proportional, then it becomes this, which is represented as this. So it's not really a matter of why should it be this or that. It depends on the relationship between the two quantities under consideration.
So when can it be D?
When can it be D?
Yes.
Yeah, if it's not following a straight line, if the relationship is not straight. So it depends on if you have plotted the graph, that's when you know whether it should be this or that. You understand? because it can be inversely proportional at the same time. It will not be straight. It will be curving. Yeah. It's only straight if equal quantity of this one gives equal quantity of the other one. That's only when it becomes straight. But when equal quantity of this one is giving inconsistent quantity of the other one, then it doesn't go straight. Do you see the next question I have on my screen? Because can you see the next question? Yeah. The answer is very clever. Is it clear? Which of the following device is used in storing charges? Which device do they use in storing charges? Capacitor. Okay. Transformer is used to increase or decrease EMF.
Yes, I do.
Ammeter is for measuring current. As potentiometer is used to. So I'm seeing the one on my screen now, 33 and stuff like that.
How are you doing that? Hello?
Yeah, Chika, are you there?
Yes, I'm here.
Yeah. So I'll log off. I'll join you back. Then we'll look at chemistry.
So by what time?
This is 6:41. 7 8. By sharp 8.
Okay, so.
Yeah. So thank you. The numbers that we are not solved, you send them to me so that when I join back again, we'll be able to solve it.
Okay.